Okay, so here is the video for class number 23 and an example, and I took this out of Shigley, and you can see that this is problem 373, 641, 721, and 722. Wow, they used this problem a lot. And you've probably recognized it. I think it was a homework problem, so I guess I need to, I don't think any students in the future, if I assign this problem. I usually change the numbers. Hopefully this won't be helping too many people who are trying to get away without doing their homework. But anyway, I started out with these this information here. This is the layout, and with 11 kilonewtons right here. And then we're able to figure out what FB is going to be in both the Y direction and Z direction. And we get the transmitted torque. And if you can't do that at this point, let's have a conversation. But we want to redesign this shaft to determine the diameters based on a modified Goodman safety factor of 2. With the fully corrected endurance strength of 160. We get the yield strength. So all this stuff has already been chosen. Some of this you will have to choose, right? And then I say the maximum moment that at A is 2043, right? So that's going to be right here at the center of A, and 4097 right here at the center of B. And as designed, they get a 0.39. Here's your shear moment diagram. So you're going to have to do all of this by hand, but then we're going to proceed with the rest of it. Now, I want to see calculations by hand, but I also want to suggest that we do this in Excel, so I will try to do that live here. I don't have it like I've actually done it a couple times before, but you know, I don't necessarily have that right in front of me. So I'm going to start an Excel spreadsheet fresh. Actually, I could probably open up one. Yeah, I could probably open up one over to the side where I've done it right here. So I just for my own sake to take a peek. So let's see. Well, I don't have it in there. No, I know where it is. It's under assignments. All right. So if you pause really quickly, you might be able to see all of my answers. Maybe. Really quickly. You got to be quick. Boom, because I'm moving them over. There you go. And I think I got all my. I think I got it. Okay. So what I would do. All right. So first, I'm going to cheat by grabbing a lot of this stuff. I do this all the time. Right? Oh no, I could just grab that. Okay. And I put it over here so I don't have to look back and forth at it. Right. And let me see. I'm also going to cheat because I need this equation right here. Right now, like I said in the 11th edition, you're actually I might actually even mark this thing up a little bit here. Let me mark this up in Paint. Ooh, it got really small all of a sudden. Okay. We don't need some of these things. All right, so first off, we don't need this top equation. Although it might be a good idea to like double as a double check. So I'm going to leave it in there. But things that we don't care about. We don't have an alternating torque, and we don't have a mid-range moment right there. So we can get rid of looking at those. So when we go to type out our equations, we don't have to. And when we go to build the stuff, we don't have to include those, which is kind of nice. All right, so I just wanted to mark that up and put this in here. You don't have to do this. I'm just merely telling you the method to my madness. There you go. All right, so one way to do this is to start with something useful. I'm going to have my S. I might add some columns and stuff later on, so I guess I could just start on the top corner. So I'm going to have my ultimate right here at the top, and then I'll have my endurance. And you might want to go through the process somewhere over here in some spot. You could even do it on a separate sheet, whatever, to create there. So My ultimate strength is 440, and label it. And always that makes the P small for whatever reason. And I'm particular enough that I just want the right thing. And these are going to be inputs, so I remind myself by doing the yellow. I use yellow as my input for things. And we said 160 was our, there we go. So maybe I want to go my moment right here, and I might even go M. Nah, I guess go M, and then I'll go T, and maybe I want to go KF, maybe KFS, right? And yeah. So what else do I have? Oh, I want to have my safety factor right in there. There's my safety factor. And what else do I want to do right there? All right, I might say here's going to be my preliminary diameter. And then I might go D and I go actual, right? Let's make this look good. We could do this later, but we highlight. Okay, so first you click into here. Click back up into this section, highlight, right-click, format cell, and go subscript. It just makes it look better, right? And you don't have to do it, but wouldn't hurt. Sometimes I'll actually even over here say ultimate strength. And then endurance strength and safety fatigue safety factor. And maybe I'll be lazy there. And then moment torque normal fatigue, stress, concentration. Once again, you don't have to write these things, but it really does help to like keep track. And you're going to see in a second, I'm going to do something that is going to help me with the repetitive nature of the thing. But for the time being, I'm putting the units right next to this thing. A lot of times I will write the source onto the next column right there, right? And we don't have to write all this stuff out. And if you want to, you could just zip ahead a little bit. Calculated diameter. And then I'm going to go selected diameter. And I'm going to go yield safety factor. Boom. And I might go at NY right there, right? So subscript. And by the way, you could cheat by not having to do that every time by just coming back in here. And sometimes you have to actually go back and forth onto the thing, but you could just to the right side, and now you don't have to do the subscripts everywhere, right? And you could even like cheat by going down to this right here and just go to K. To the left of it, it'll use the it won't do the subscripts onto the thing. So just saves you a little bit of time. So here we go. So this is an input, and this actually should be a design. This actually should be D maybe, or maybe DF, design for fatigue, right? And that's I said 2 in this case for here. The moment is going to be in Newton meters. The torque is going to be in Newton meters, and this is going to be. I'm going to leave this in meters. And later on, we will. I will select this. So when I'm going to put this, a lot of times I will put a different color for something that's a decision that I had to make afterwards. So anyway, so the moment that I was told right here was, first I'm going to pick it up for B, right? The worst case, 4097. The torque was the 3101. And I guess that these are inputs that I'm making here, but I'm going to make these orange because I have my daughter is like doing things. Anyway, my daughter's sending me text messages. It's bothering me. Not bothering me. Your daughter doesn't bother me, but that's okay. KF, let's see. Okay, so these are things I look up too. So boy, I'm really going to be coloring a lot of these things. But see, I'm basing it on here, and I can't rely on my memory. That's why I'm copying and pasting these things over here. I'll probably get rid of it here in a second. Let's see, the KF that I'm going to use for this is going to be 2.14 because I'm doing it right for the center, right? So I found that it was going to be at B, and this is the moment that's at the center of B. We're going to fix that here in a minute. And then the KF S is 3. All right, so this one, I'm going to make sure this one does not turn. Oh, no, I'll hit no fill. I'll go no fill right there. No fill right in there because I'm kind of tired of it doing the thing. So now I'm going to go and use this equation to figure out my diameter. So I'm going to go equal to, open parentheses, 16 times the design factor, but I'm going to hit F4. So I always use that cell. Nope, it's not doing it. Oh, because I see, because I didn't have that function turned in. So you see that it puts the dollar signs next to the C and next to the 4, and then I'm going to divide it by pi, which is pi parentheses, and then I'm going to multiply that by, and I'm going to start a new quantity, which is going to be a big one, right there, and so we're going to have 1 divided by the endurance strength, right? But that endurance strength needs to be 1 million. So I'm also going to divide by 1e6. So I said a divide. I could have put it in parentheses and times it, but it's just a little simpler this way. And then I'm going to multiply it by the quantity, right? So now we have to go, we're at this spot. We're going to go 4 times KF. And I messed up. I need to go back a little bit while I remember. Go next to that C3 and hit the F4 button again. I want those dollar signs in there. Okay. Now I want to go. I'm back over here, right there, and I'm times the KF, and I don't need the dollar signs, times the moment, and I messed up. I need to have parentheses before that KF and close parentheses and then raise it to the square, right? So I'm right there. And okay, so I messed something else up. I want to close that parentheses. So that parentheses was before the 4. I need to take the square root of what's inside here. So I'm going to go SQRT. Right there. So I know I'm jumping around a little bit. That's why my brain works. All right, so I think I have everything. 1 over SE and divided by 1 million because this SE up here was in megapascals, and I want everything in base units, so I'm going to reduce it down to newtons and meters. Okay, and now I think I'm good. So I'm going to go plus 1 divided by my ultimate strength, put the F4 in there, divided by 1e6 again. All right, and then now I'm going to multiply it, and it's going to be by the square root of that whole thing. So this time I'll remember ahead of time, SQRT, parentheses, and now I'm going to have 3 times, and now inside a parentheses I need KFS times torque, close parentheses, raised to the square. Right now I'm going to close the parentheses for the square root. And then I'm going to close the parentheses. Sometimes it's good to, you can watch the colors move onto this thing, but it's almost always mess this up. Right there. You can kind of see that was a parentheses that closed that parentheses. And then the last one is the close this parentheses. Let's see. So I'll move my cursor so we can see it if it happens. There you go. We saw it blink. So we saw there. And now we're going to raise it to the 1/3, right? Because we need the cube root. So I had raised to 1 divided by 3, close parentheses, boom. So I get, in my preliminary here, I can get these people to shut up. Not my daughter. I don't mean my daughter. But, let's see. Okay, so, 1.1142. So let me take a look at my previous hand calculations of this. And did I mess anything up right here? I think I might have. No, 1 second. I gotta sneeze. All right, so I got a different value. I got 0.1210. So let me pause and see if I messed anything up. No, I think it's okay. I think what I did is I used the fillet instead for some reason in previous versions. So this is okay. So right here, what I'm going to use, I'm going to go 110. In the previous one, I had to do 120 in my hand calculations. So I used KT instead of K. I mean, they're saying these are KTs, and we really should adjust these from with the Q, right? But I didn't. But we could. And it says, do not use these once actual dimensions are available. But we're going to anyway. But I'm going to leave them. This is for the keyway. And then the next thing I also want to do is I want to check for yield, for first cycle yield. So that's the reason why. Oh, by the way, maybe I should keep this as 0.11, right? Because this is what I'm putting in there based on the preferred sizes. I was losing it. Very distracted today. The other equation here, we want to double check this guy. Bring him back in here. And I'm going to get rid of my... Well, no, I'll keep him because I might need him in a bit. And for the yield safety factor, we'll go equals square root of... and wait, we want to go maybe we need the yield strength, so maybe I'll insert a line, and maybe I'll insert a line up here. That's a better line, and I'll go yield strength. And make this a Y here, backspace. And the yield strength, we were told 370. And make this megapascals right here. Boom. Okay, so down here, I'll say yield strength. Because I'm going to use this again. I'm going to hit the F4 button times 1E6, right? Divided by, and then go, this is going to be this, I'll go square root because that's the whole thing is squared. And then I'm going to take parentheses 32 times that guy times, where are you? Where are you? Moment. Right? And you see that there's alternating a mid-range, but we only have a mid-range. And that's, well, actually we don't need to close parentheses yet, because okay, we could divide by pi and then divide by this diameter cubed. And now we can close the parentheses, right? And now we go plus 3 times, and boom, boom, boom. No, we don't need a parentheses. We could just go 16 times KFS times the torque. Nope. We did need the parentheses because we needed to square everything. So I did the parentheses before the 16. And then I did the divide, and by pi, and I'll divide again by d cubed. Well, not that d cubed. I want this d cubed. I want the actual one. Okay. And we're going to close the parentheses. So it'll be 3, because that's 3 times all of that, and then it needs to be squared. And then I think one more parentheses. Yeah. All right, so I got a safety factor of 6. All right, so hopefully that's satisfactory. So with that, it's kind of surprising. This is okay. But now let's do this for the other locations, right? So some of the other locations. So I've made this like little thing right here, and it's nice to put all these little borders onto it, but above it, let's have this be our axial location right here. Okay, so I might like maybe make this a little bit more useful by no, I think we could do this by hand, or I could try to automate this a little by trying to incorporate. See, I think I can get rid of him. I think I trust him, and I think I can get rid of that guy. I want these stress concentrations a little bit. But what I'm saying is, okay, let me explain. I'm going to insert a couple before, because there's a couple places I want to do. I want to do the diameter that's right here, the diameter in the center, which is the one I just did, and then a diameter just to the right of this, and then a diameter right here, the diameter here, and this is actually this is the one we just did, and then a diameter here. So I want like six diameters that I want to play around with. And so here we go. No, I think I only need one to the side of this, and I need 4 in between here. All right. Yeah. And so in labeling these, this is the center of A. I think I have one too many. Yeah, I think I have one too many somehow. There you go. And this is the center of B, right? Along the shaft, right? Because here's the gear center and the gear center, and I only care about right here, here, and here, 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 and there. So in terms of our locations from the center of the gear, we want to subtract out from this diagram. All these measurements are. Oh no, this. Okay, all these. Yeah, we can do it either way. But like here, I'm just going to put in 350, because this is this one. Let's see. We'll make this all centered. This first column is going to be that location. This next one is this location, which is 400, and this next location is going to be 425 minus 15 is going to be 410. Right, so this is the axial position down the length of this shaft. This guy is the 400 plus the 350, so he's the 750. And this is a little harder to do right here. I think, okay, so the distance between 285 and 325, got to do that in my head. That's only 40, right? Or is that 50? No, that's 40. All right, so there's 40 right in there. So we're going to take 20 to either side, I think. So this comes out to 730, and this comes out to 770. Don't quote me on that, right? But anyway, so let me copy all of this stuff in all of these, right? And then we're going to modify them to based on their location, right? So let's start here with the 350. There's no torque there. Boom. That's good. And the stress concentration that we're going to use, we could use a well-rounded fillet, right? So our well-rounded fillet is going to be 1.7 and 1.5. So we'll change this 1.7, 1.5. Boom. And the moment is going to be, okay, so the moment right here, we have to actually do this math, do a little bit of the math there. So we have 5083 newtons times the number of millimeters right there. So it's going to be less than 2033. Ooh, we should actually, see it. That's why I was thinking about making more rows. And then you might consider making more rows so that you could do this automated, like a little bit more. But let's see. Making this really long video. I didn't mean to. I should just a scratch piece of paper, but do it on the back. Sure, do it on the back. All right. So we have these shear moment diagrams. Guess I could do it right up in here. There you go. We're going to zoom in on this, right? If we can get the thing to focus. All right, so here is the original shear moment diagrams right here, going through these pieces right there. And I'll do it over here too. My pencil is too thick. But, yeah. Wish I had made that better. I don't care, but see, it's so small. My pencil is so thick. There you go. All right, so just to this side and just to that side, because we're trying to minimize our weight, so we don't want to like get overly generous with our extra conservative. We want to start zooming in onto things to try to avoid unnecessary conservatism. So right here in this spot, which we could have labeled lots of different things, we're going to take, instead of 0.4, we could take, what did I say? What did I use? 0.35, right? If I did that correctly. So 0.35 times our 5083. And we end up with 1,779 there. But we want to do it over here too, and that's going to be pretty small because that's just the 494 times 0.385. 0.35. If I did that correctly. Now I'm starting to question myself if I did this correctly. 0.350. No, it should be 385 minus 15. What does 385 minus 15? Should be 370, right? Yeah. Yes. That's why I should have done the thing automated. But anyway. So the 0.37 times our 494 was 183, and 0.37 times 5083 is 1881. So the moment at that location we could find with this. That's why I'm saying that this could be, done a lot more conveniently by way of doing it in Excel, right? So we just get 188. Let's call it 1889, right? Newton meters. All right, so we're plugging this back into here. So in here, 1889. Okay. This is the center of the thing. All right. So that's fine. So we end up finding we could make this 75 right there. So 0.075, and we needed to move all of this right over there. Okay, so I actually made a mistake by way of, we didn't, I guess I was trying, we could have just left all of these. We didn't have to do the double dollar signs onto all of that. I was going to try to keep that over to the side, but I guess I changed my mind as I was coming through there. So it might actually be better if we were to fix this thing I just did up there. But let's leave it for now. But I don't necessarily have to do the dollar signs because I shifted everything over. Anyway, because I repeated the material properties. Normally I would just keep it up over to the side. So I don't have to repeat it. But I don't know. What did I say? Nothing. But anyway, so why is that so huge? Yeah, I mean, something going on right here. Why is that such a huge safety factor? Damn. Okay, here, I found a mistake, and this is something I really, really, really want to emphasize. If you find a mistake in your Excel spreadsheet or you get a stupid number, do not leave it. Do not wait, and do not just, oh, well, I just guess it was something crazy. Solve it. Solve the problem. Figure out what you did wrong. Backtrack and solve the thing. So in my yield safety factor here, I neglected to raise this to the square. I didn't square this. So actual safety factor is this. All right, so I got a weird number when I went to change the thing around because I didn't have a torque in there. So here's the yield safety factor. All right, so it makes sense now. Okay, so A, that is now going to be the moment that I got was going to be 2083. Boom. And so I could get away with, instead of 110 like I did in this other one, I could get away with 100, right? So there you go. There's my, that's the diameter I'm saying. I got 0.098. Well, I can pick 100. For this next one up right here, well, no, this next guy, it's going to be the same torque, but it's going to be slightly less than 2083. So this one, what I can do is trying to remember let's see, what is 425 minus 385? Here, I'm looking at this right here. I want to find the width of that. I know it's stupid, but it's 40. Okay, so I need to subtract 20. Right, so this is going to be 20 here, so it's going to be, well, actually, it's going to be slightly more, right? Okay, so it's going to be slightly more, and that slightly more is going to be 20 times 1320, or 0.02 times 1321, and I'm going to add that to the 2033. Boom. So now that becomes so the moment there is 2059, and now this one is like a little ridiculous right here, because that's it's going to be 2059, but this one is now going to be a little higher. So we started out with what does that say? I can't even read that. It says 198, right? Well, negative 198, but I'm going to add to it a 9843 times my 0.02, right? And that's actually nearly zero, right? Actually, this nearly crosses the zero line, because I get 197 and 198. So basically, it's just going to be 2059. All right, so dinner time coming up here, so we're going to end this thing. It's already been too long. But right there, I'm going to go 2059, 2059, boom. But I said we might want to use sharper corners right there next to that thing. So we go should be 2.7 and 2.7 and 2.2. And we get okay, so we get 99. So we could use 100, but see this one right here. We could actually use 100 there too. Okay, so good, 100. So that's what we've decided. This one right here, this is the original one. So we had 110 right there. This is going to be. Let's take a look at that location. So that is now going to be to the left of this. So that's actually going to be a little bit less. This is the peak right there, that 2496 right there. And then also right over here, it's going to be slightly less. All right. Over here, it's going to be slightly less and slightly less. So we need to find those other locations. So for lack of time, I'm going to throw in numbers, but we could actually get those numbers, and then I will describe some of the logic that we would use after the fact. All right, so it's not letting me go. There you go. So right here, I'm going to say that let's say that it went down to I don't know, 3,800. There you go, 3,800. Probably not that much. And let's say over here is 3,700. Right? I don't know. This one, and what we have to do the same shoulder. We're going to tight shoulders. So 2.7 and 2.2. Right here we need more than 110. So by the way, these are the same diameters, right? The one that's being decided by these two, and the one that's being decided by these two, they're connected to each other. So you want to pick the larger of the two, right? So if this one is picking, and I don't know why I picked 110 right now based on this. Did I change anything? I don't think I did. Let me see. Is anything wrong? No. Saying we're doing the same thing. Okay. So this one, I think we want to pick 120. And I think this one we want to pick 120. I don't know why I picked 110 before. Yeah. So, yeah, both of these kind of say that we want to pick 120. For this one, we don't have a torque, so we can get rid of that torque. And we see that we get, close to 100. Boy, it sure would be nice. But now we have to make some decisions about this. Maybe we want to refine that stress concentration. Make it a little bit bigger. Oh, no, we could have made it. Oh, we were able to. Wait, this is the stress concentration to use there. Yep. Okay, yeah, so we can make this 100 if we wanted to. We can almost make it, we could make it 95.095. But now we have to make a decision about, because, okay, so we went from 75 to 100, right? And then we're going to have to go up a size, to go to the middle part. And then we're going to drop down, and then we're going to drop down again, right? So based on these results, these preliminary results, let's sketch the thing out. I think I sketched it on another piece of paper somewhere. I know I had it somewhere. There you go. This is like a necessary thing to try to do. It's like, okay, so right here, we said that we had, as my preliminary, I said I could have, my short attention span, I can't remember. I could have 75. So I'm going to write all these down right here. And I guess, all right, so right here I said I wanted 100. And then here we said we had to have 120, and then here I had to have 95. All right, so, but what size do we want to have right here, right? So we want to go, we don't want to jump too high from here to here. This is the largest one that we have so far, but this needs to be larger. And so we take 120, what's times 1.2? I get 1.44. So that 150 here. But we got to be careful. Oh, no. Okay, so now we're okay because that 150 and 100, they're fine. But what about this next step down from this is 95 and 100. No, that's a 75. Sorry. That's a 75 and 100. So 75 and 100. 75 divided by 100, nope, because sorry, it's the other way around. 100 divided by 75 is 1.33, so this is fine right there. So we're okay. This is 95. What 120 divided by 95? 1.26. So this is okay right here too. And then lastly, right? So far this design is fine, but we might have to make some decisions and some compromises by way of having that 1.2 to 1.5 thing. You have to double check all these. So let's take one last look at our. Let's take a look at what we might do for the bearings, right? So that's our last little bit here. Our bearings, our reaction. We want to have the same bearing. Would be nice if it's possible. But we have the largest one that we can see here is definitely going to be on this side. That's the 8,319 and the 10,000. So let me write that down. With the square root of the square of 8,319 squared plus 10,830 squared, right? So that's going to be the reaction at, did they give it a name? That's C, right? The reaction at C. So RC, the total reaction right there, is going to be 8,319 squared and 10,830 squared. And so we're going to get 13,656. These are newtons. And therefore, CT min, I said was to take 3 times it. We're going to use kilonewtons, so I'll take it as 13.66. So 3 times that. So we're going to have 40.97 kilonewtons is what we need to find. So I want to look up in Shigley under Chapter 11, and I said the table 11.2, and I said to use a deep groove and C10. And if we're going to do that, we need to have something that's larger than 40.97. So we could get away with the 55 if we wanted. We can get away with the 55. So 55 millimeter bore or larger. Oh, and by the way, while we're there, let's take a look and also mention that when we look for this, look for the width of it, right? Because that's going to be the width that we want to include. But also it's got a fillet radius, and it jumps up into the next one. So we say, oh, yeah, no, actually I said I had to go to the next one up. I had to have 55, right? So it has a 1.5 millimeter fillet radius and a 21 width. So coming back to all of this, so what's 75 and dropping? Well, actually 95. Oh no, I guess we have to make if we want these to be the same size, right? For the thing, we got to figure out what is 75 divided by 1.2, right? That's like 62.5. Right, so we can't go any larger than that, right? But 95 divided by 1.5 is 63, right? So we almost need to be right there at the 65 or 60, right? We could go 60. Can we go 75 divided by 60? 1.25. How about 95 divided by 60? 1.58. It's too much, right? What about 75 divided by 65? 1.15. So we're kind of stuck in this particular situation right here. So we might actually want to, just for the sake of the bearings, go up to 80 right here, and then we could go to 60. Right, 60 and 80. That gives us 1.33 and 95. Whoops. That's the 1.5. So what about the 80 and the 65? Okay, the 80 and the 65 would be okay. What about the 95 and the 65? 1.46. So 65 millimeters is the way to go in here. And we'll adjust that and make that 80. And then we're still okay with our 100 and our 80, right? Yeah, 1.25. So there you go. There's the design for the thing. We've made this 65 millimeters and 65 millimeters. And we've obeyed these constraints for the thing. So that's the design for stress. And this is a really long video, and I messed things up. But it should be helpful for the project.